So we're just going to look at the review. Focusing on differentiation from first instance. It says the limit as h to 0 of f of x plus h minus f of x all divided by h. Right? So this is the formula or the principle that we're doing. So the question is f of x is equal to x squared minus 3x plus 4. So we are asked to use first principle to differentiate this question. F of x is equal to x squared minus 3x plus 4. So we know right away that f of x is what we have right here. But what we need to find is what is f of x plus h. Now, f of x is given as this, so that means f of x plus h. That means anywhere I see x, I'm going to put x plus h. So what we're going to end up with x plus h all squared minus 3 times x plus h plus 4. X plus h all squared, meaning that x plus h is multiplying by itself. So it is going to be x squared plus 2xh plus h squared. And this is multiplying by 3. So this is going to be 3x minus 3h plus 4. Alright, so all of this multiplied by itself times negative 3, and we still have the plus 4. So what we end up with? Alright, you just have to keep as is because there's no like term. X squared, h squared, 2xh minus 3x minus 3h plus h. Alright, so there's nothing to simplify. So the derivative of f of x is going to be the limit as h tends to 0. F of x plus h, which is going to give us all of this. Let's see if we can get all of it there. X squared plus 2xh plus h squared minus 3x minus 3h plus 4 minus f of x, which is x squared minus 3x plus 4 all divided by h. So what we can do is look at the like terms and cancel or simplify however you want to look at it. So this is going to be equal to the limit as h tends to 0. We're going to have x squared plus 2xh plus h squared minus 3x minus 3h plus 4. And the negative will multiply this bracket. So we're going to get minus x squared plus 3x minus 4 all divided by h. Now let's look at what can cancel. X squared will cancel with x squared, 3x will cancel with 3x, and 4 will cancel with 4. Alright? Positive, negative, negative, positive, positive, negative. So they cancel out each other. Alright? So then what are we left with? We're left with limit as h tends to 0 of what? 2xh plus h squared minus 3h, that's it, all divided by h. Now notice, in the numerator, h is common between each of the terms. So what can we do? Factor out h. Alright? So we're now going to have the limit as h tends to 0 of h times 2x plus h minus 3 all divided by h. These two h's will cancel. One in the numerator, one in the denominator, one is multiplying, one is dividing, so they are performing opposite operations, so they cancel each other. Now, and then one of the things that you can do by doing regular differentiation, you can check to see if your answer is going to be correct. Because right here, we could have gone ahead and figured out that when we differentiate this, we're just going to get 2x minus 3 as the answer. So when I'm finished here, all this long working out that we're looking at, that sometimes we even wonder, why do we need to do this? All this long working out that we're looking at must move from question to answer to give us 2x minus 3. Let's see if we can wrap this up. We're going to get that the derivative of x is equal to the limit as h tends to 0 of 2x plus h minus 3. Now, as h tends to 0, which means h is equal to 0 when we're doing substituting. So when h is equal to 0, we're going to have 2x plus 0 minus 3, which is going to plus 2x minus 3. So that's all we would get for the answer by using differentiation from first principle. Okay? So we must bear this in mind as we do our preparation. Must take these things into consideration in our preparation for the exam. Okay. So after you finish with that, it says hence find the gradient at the point negative 1, 4. All right. If we're going to find the gradient, it's going to be f of f prime x. Well, yeah, let's write it back. 2x minus 3. So it is when x equal to -1. So f prime of -1 is going to equal to 2 times -3. So this is -2 minus 3. So it's equal to -5. What is this saying? This is saying that the gradient at the point -1, 4 is going to be equal to -5, which means that the graph is decreasing at that point. Please note that this graph is a minimum graph. How do we know that it's a minimum? Let's look at it real quick. So f of x, and we could have checked it, but let's look at it real quick. F of x is equal to x squared minus 3x plus 4. And notice a here is equal to what? What is a in this question? What's the coefficient of x squared in this question? The number that comes before x squared here, what is that number? 1. So since a is equal to 1, then that means we have a minimum function. Alright? So that means that the graph, well, this part, not a part of the question. So the graph is going to come down and go like that. Alright? So we know that it's a minimum. Saying that the gradient is negative, please note that the point which is negative on the x-axis is going to be on this side. So this is where -1 is, and 4 is going to be, say, for instance, right? So the point -1, 4 would be this point. So notice that the graph comes down on this side and then goes up on that side. Right? So that's the reason why the gradient is a negative. All right, so we're good with that. Anything we need to clarify about it? Huh? No. All right. Say, for instance, we give the function. So this is the next part to the question. F of x is equal to 3x plus 1 times sine x plus 2. Product, because both of them are multiplying. So say, for instance, we say that this is u and we say that this is v. Remember, the product rule says if you're differentiating with respect to x, u times v is going to be equal to u times the derivative of v with respect to x plus v times the derivative of u with respect to x. Right? So this is going to give us, if we have u which is equal to 3x plus 1, when we differentiate u with respect to x, what would we end up with? 3x plus 1 differentiate, what do you get when you differentiate? Somebody? 3, wonderful. V is equal to sine x plus 2. When you differentiate v with respect to x, what do you end up with? Derivative of sine is wonderful. So f prime x is going to be equal to, so notice u times the derivative of v, and then v times the derivative of u, cross multiply based on what we have here. So it is going to be cos x times 3x plus 1 plus 3 times sine x plus 2. Cos times 3x is going to give us x cos x. 1 times cos x, 3 times sine x, 3 sine x, and 3 times 2, 6. That's your final answer. Say. Say we have f of x is equal to 2e to the 4x plus cos x. All right. So we look at um, the integral of e to the cos x already. What do we get when we differentiate e to the cos x? Sorry, e to the x. What is the derivative of e to the x? All right. So when we integrate e to the x with respect to x, we get back b to the x plus c. Right? So if we have y is equal to e to the x, and then we are going to take the derivative of it, what do we end up with? So it is going to be e to the x times the derivative of the power. But the derivative of the power in this case is 1. So when you differentiate e to the x, you just get back. You just get back? No. Alright, so let's go. What is the derivative of x right here? Then differentiate x again? 1. So the derivative of e to the x is just no e to the x. Let's go again. What is the derivative of e to the x? E to the x. How is that so? Because the derivative with respect to x is just going to be give you back e to the x times the derivative of the power. What is the derivative of the power? What is the derivative of the power? 1. 1 times e to the x give you back. So the derivative of e to the x is just like how the integral of e to the x is. The integral of e to the x is. Yeah, so not anything hard, man. It's right here. If you integrate e to the x with respect to x, you get back e to the x. If you take the derivative of e to the x, you're going to get back times the derivative of the power because the power can be different. I think I gave one earlier where it's e to the power of 10x, right? So you have to bear that in mind. So the power can be different. All right. So what would you get for that one? Anybody? I'll try to work it out. All right, let's go. Because we want to make sure we cover all of what we have. So the derivative of e to the x is going to give you back e to the x times the derivative of the power. So if we have the derivative of e to the 4x, well, it's 2 times e to the 4x. So when we differentiate this, we're just going to get it back. And then we're going to multiply by the derivative of the power. What is the derivative of 4x? 4. Plus, what's the derivative of cos? Negative sine. So what we therefore end up with, 4 times 2 is going to give us 8 e to the 4x minus sine x. Anything I need to clarify? So here is where we have to apply the quotient. Quotient because we are dividing. So the top part is u, bottom part is v. So if we have u is equal to 5x minus 1, then the derivative of u with respect to x, what would we end up with? You know, somebody help me. And we differentiate this, what we get? 5. V is equal to 4 plus 2x. Derivative of v with respect to x. When we differentiate 4 plus 2x, what do we end up with? Wonderful. So it is going to be dy dx is going to be equal to v times the derivative of u, so it's v, 4 plus 2x times the derivative of u, which is 5. And then 2 times the derivative of 5x minus 1, all divided by v squared, which is 4 plus 2x all squared. Alright, let's simplify. But 5 times 4, 20 plus 10x, negative 2 times 5x is going to give us negative 10x, and negative 1, negative 2 times negative 1, that's going to be 1, all divided by 4 plus 2x all squared. So when we simplify the numerator, we end up with 22 all divided by 4 plus 2x all squared. So that's going to be, so this right here is the derivative of this function. Point out part of it that you're not clear. Go ahead. 4 plus 2x, in the denominator, because it says you're divided by squared and g is 4, yeah. So we are asked to integrate this. So integration, add 1 to the power, divided by the new power. So we're going to get 4x cubed divided by 3 plus add 1 to the power divided by the new power. So notice, another way of writing this right here is going to be 1/3 x, right? So that's another way you can write. Well, let me just write it there, leave it there. So add 1 to the power divided by the new power. Add 1 to the power, we get 2 divided by the new power. So this is going to give us x squared over 6. Because you're dividing by 2, but you're already dividing by 3. Notice, already divided by 3. So if you divide by 2, which is the new power, the denominators are going to, how do you think we get 6? What do you think happen with the denominator? Multiply them. Because we're already divided by 3. Because notice, it is x over 3. So if the power now becomes 2, we're going to have to also divide by 2. So it's going to be 3 times 2, which gives us a 6, yes? And then the integral of a constant is the constant times a variable. And the variable in this case is x, because you're integrating with respect to x. So this is going to be minus x. What do we add at the end? Plus c, because it's an indefinite integral, so you have to have the constant of integration. Okay? That's right. That's right. So when it is that one, as you bear in mind, it's a definite integral because you know the specific region in which you're integrating. Well, all right. So let me ask you something. If I say 4 divided by 2, what do we get? 2. If I say a half times 4, what do we end up with? 2. So dividing by a number is the same as multiplying by the reciprocal of the number, so to speak, or 1 over the number. So if I am dividing by 2 is the same as multiplying by a half, or multiplying by 1 over the number that I'm dividing. So dividing by 2 is the same as multiplying by a half. Dividing by 3 is the same as multiplying by 1/3. So if you're dividing by the number, it is the same as multiplying by 1 over that number. So 1/3 of x is the same thing as x divided by 3. So you're dividing by 2 is the same as multiplying by a half. So whatever the number is in the denominator is going to be 1 over that. So notice, if we have, say, 16 over 4, which is going to give us 4, is the same thing as the number that is in the denominator, 1 over that number times the numerator, which is 16. Right? So what you're saying is that the denominator tells you how many parts you're breaking down the number into. Right? So that's what the denominator is. The integral of 2 cos x plus 2 over x to the 4th. Some time ago, we would have looked at a law of indices or a rule of indices that we can use to apply to this. It says if you have a to the negative n, it's equal to 1 over a to the n. Now, this is written in this form. So notice you have a number over x to the power. So it is like 1 over a to the n. So because you are going to be integrating, it is best to have it in this form because at least you can clearly identify where the power is. Yes, you can do so here, that the power is 4, but because it is 2 over x to the 4th, it's best is that you have it as more like a linear straight line rather than fraction. So you want to eliminate the denominator. So what do you think I would write if I want to write it in this form? So say we have it as 2 over x to the 4th. How would I write it so it look like this? What would you write? Pay attention to where 4 is in respect to n. Yes? X negative. Alright, so x to the negative 4. Anybody want to add to that? 2x to the negative 4. Why 2? Because the denominator is 2. So we're going to get 2x to the negative 4. So another way of writing this is the integral of 2 cos x plus 2x to the negative 4 dx. Integrate, add 1 to the power, divide by the new power, but the integral of this cos right here, which is a trig function, is going to give us what? Integral of cos? Integral of cos? Sine. So we're going to get 2 sine x. Integral, add 1 to the power, divide by the new power, add 1 to negative 4, we get? Add 1 to negative 4. Negative 3 divided by negative 3 plus c. You have a positive divided by a negative, so you're going to get 2 sine x minus 2x over 3, the negative third power plus c. Or did we get this to be a negative right here? A positive divided by a negative. Alright? Because this, even if you don't think about this plus sign right here, this is going to be a positive 2x divided by a negative 3, which will give you a negative. Right? What's the evaluate? Somebody help me now. What's the evaluate? You must get a. Alright, so when you're evaluating, you need a finite answer. Not an evaluate means that you must get a number answer. Right? Just like when you say to solve. So you must get a finite answer for this problem. So this answer right here, because it's an indefinite, because we don't know the value of c, it's not finite. Because unless you know the value of c, um, and c can take on any value based on their function. Integrate, add 1 to the power divided by the new power, so it's 5x squared over 2 plus integral of the constant 4x, and we are integrating from 1 to 3. So this is when x is 3 and when x is 1. So this is going to be 5 times 3 squared over 2 plus 4 times 3, and then minus 5 times 1 squared over 2 plus 4 times 1. 45 over 2 plus 12, and this is going to be 5 over 2 plus 4. So over this side is going to give us 69 over 2 minus over this side, which is going to be 13 over 2. So we end up with 56 over 2, which is going to give us what? Must be. So we end up with 28. Right? So you must get a finite answer. Evaluate finite answer. Integral of cos. Integral of cos, yes. We get negative sine x, and then we're integrating from pi over 4 to pi over 2. Now, because your calculator is not in radian mode, you have to bear in mind that pi is equal to 180, because you're going to put in the degrees in your calculator and not pi. Because some calculator have the pi symbol on it. For you, you don't put in the pi symbol because the calculator is not in radian mode. So this is going to be pi over 2 is what in degrees? 180 divided by 2, 90. All right. So um, negative sine of pi over 4. Now, please note you can write 90 there. 90 was not given to you. You are going to put in 90 in your calculator. So you're going to say the sine of 90. The calculator there. What you get when you put in sine of 90? You should remember it though, but as an answer, you should remember it, so I have to keep it in time. Alright? Because it is stuff that we would have looked at. Huh? One. Yeah, I must get one. No, I didn't say you were wrong. Okay. So right here we're going to get negative 1. The sine of 90 is 1 multiplied by negative, so we get 1 minus. Now pi over 4 is what in degrees? Now let's go again. Pi over 4 is what in degrees? Pi is equal to – divide by 4. Let's go. 180 divided by 4. 45, yes. So the sign of 45 is going to equals what? 0.707, yes? That's what you get? So this is going to be negative 1 plus 0.707 because it's negative times the negative. So it gives us a positive. Negative 1 plus 0.707 is going to give us negative 0.303. Get that answer? Alright, give me a second. This is loading. And we basically soon finish with this part of the exam. The only other part we would not have to start is multiple choice, which we can do. Tell me. All right, so look at it and see if we can work to it. If we have 45 over 2 plus 12, what would we do to add these two numbers? Mm, 22 goes one times, 45. 22 goes two times, 24. 45 plus 24, 69 over 2. Yeah. Wait. I defeat myself, and I don't listen to nothing when I say, man. So we are trying. Yeah, but mine. Oh, but on the side. Alright. Here's of art. I've always said this. If you have years of doing something, you're doing it wrong. So the moment correction and clarity come, I've always said if people continue to do the wrong thing, then it's either you're an insane person or you just don't want correction. Yeah, but then you have to go fix that. You need to go with it and deal with it. Because what I'm saying to you is this question to you, and remember, you're learning at the same time. So it means that if you see something on the board that you don't understand, that means you need to ask about it. Because we can't allow the exam to pass us by and we just don't feel it. If you notice, you're not sure we get the 69, you ask about it. What's wrong with that? You have to ask about the things that you don't know because you're learning at the same time. So the next question is this. Is there something on the board that you're looking at that you say, I want to do this and I'm not sure? Even something that we did earlier. Yes. X plus 4 and then is the answer 2. Squirrel. Okay. All right. So we have to bear in mind the rule for differentiation. So just gonna point something out to you. We get y is equal to x to the n. To differentiate, it's going to be the derivative of the function. The function is y, but it is written in terms of x, and it's going to be equal to n x to the n minus 1. So let's look at what we do. How do you differentiate? You take the power and multiply. So multiply, then subtract 1 from the power. So you multiply by the power, then subtract 1. So look at all this right now. Say for instance, you have y is equal to 4 plus 2x. What is the power of this x right here? So anybody? 1. Right? So what you are going to do? So I'm going to differentiate this with respect to x. The derivative of a constant. What is the derivative of a constant? How am I going to remember? Write it down. What did I just ask? What is the? So I ask myself that question. How may I ask myself that question there? I write down that question in the book. What is the answer? You write the answer beside. So we learn. So every time we look back in my book, I must see that there, that when I differentiate a constant or differentiate a number, it's going to be equal to 0. Now, what I would have also said as well, if you differentiate a number just times the variable, which means that there is no power, or the power is 1. The derivative of a constant times a variable is just the constant. But you don't have to remember it. The power here, as we indicate, was 1. 1 times 2. 2. When we subtract 1, we're going to get x to the. Anything to the power of 0 is equal to. Anything to the power of 0 is equal to 1. So that means this is 2 times x to the 0. So this is going to be 2 times 1, which is equal to 2. So that's how we get the 2. So you multiply by the power and then subtract 1. So you multiply first, then subtract 1. Right? So the rule for definite integral, I think I hear you alluding to if we have to subtract. The rule for it Once you have a definite integral, so you have from a to b of f of x dx. Once you integrate, it's going to be equal to f of b from a to b, which means that this right here so is a integral function, or the function that you get after integrating. So it is going to be, sorry, x, sorry, x. So it's going to be f of b, which means that we're putting the number at the upper limit, minus f of a, which is the lower limit. So that's all. Once it's a definite integral, that's all we have to work it. Whatever you get for the answer after integrating the function, we're going to substitute in the upper limit minus the result after taking the lower limit. Right? So first you integrate. So notice the integral of cos is negative sign. So first you integrate. And then you know that you have the upper limit of the integral and then you have the lower limit of the integral. So you're going to substitute in the value of the upper limit. So notice, this is the integral of the function. So right here, so, would be represented by this f of x right here. So once you integrate this, you get this. And then you still have the limits. So we integrate cos. What do we get? Negative sign. But you still have the limits by which you are integrating or to which you are integrating. So you substitute in this value for x. Just as though we replace x with b and then x with a. So we substitute in 90 on this side. Minus substituting 45 on this side. So we work out 90, negative 1. Work out 45, negative 0.707. And then we simplify to the answer. So first, integrate. Just as we did here, integrate 5x squared over 2. Integrate 4x, sorry, integrate 4x. Still have the limits through which we are integrating. Upper limit, where x is, which is here. Lower limit, where x is, which is here. Work out this side, 69 over 2. Work out this side, 13 over 2. And then we subtract, final answer, 28. Alright, so that's how you have to work it out when you're doing a definite integral. Same thing for this. It says to find the area bounded by the curve and that. So what this curve would have the general look x, y. So y is equal to 2x squared plus 3. So right here, so when the graph touches the y-axis, that's going to be, right? And they're saying that the curve is bounded by the lines x equal to 1. So that's this line right here at 1. And x equal to 5. That's say this line right here, 5. And the x-axis, which is this line right here. So this little portion right in here, so that is under this curve, between the lower limit of 1 and the upper limit of 5, all of this portion, I want to find the area of it. So the area is going to be equal to the integral from the lower limit, 1, to the upper limit, 5, of the function 2x squared plus 3 with respect to x. You're going to integrate, then substitute in the limits. When we're integrating, what do we do with the power? Add 1. So we're going to get 2x today, 3 divided by 3, and the integral of 3 is 3x. From 1 to 5. So I'm going to put in when x is 1 and when x is 5. There's going to be 2 times 5 cubed divided by 3 plus 3 times 5 and then minus 2 times 1 cubed over 3 plus 3 times 1. 5, 5 to the third power is going to give us 125 times it by 2, we get 250. 250 divided by 3. All right. So, and then, so we're going to get, all right, 250 divided by 3 plus 15 minus 2 over 3 plus 3. So on this side, we're going to end up with 295 over 3. I don't know this way. So we're going to end up with 295 over 3 minus 11 over 3, which is going to give us a final answer of 284 over 3. So that's going to be our final answer, and you must write unit squared at the end because area is measured in squared units. Two 84 is an even number, so if you divide by 3, you're going to get a fraction of a decimal, so you can leave it like that. But this question closes off the structured part of the exam. Right, so time one, tomorrow, sure. Yeah, sorry. So we're given the gradient function. So please note you get your gradient function when you would have differentiated a regular function. Yes? And your gradient function is what we call the first derivative. Yes? Also known as the first derivative. So once you're asked to find a gradient after you have differentiated, you know you have your gradient function. So we have the integral of dy dx with respect to x is equal to the integral of 4x squared plus 2x minus 1 dx. Integrate 4x cubed over 3, 2x squared over 2 minus x plus c. So only there so we can simplify. So y is equal to 4x cubed over 3 plus x squared minus x c when x is equal to 0 and y is equal to 2. Because why do we use this? Because it says this curve, this equation must pass through this point. So the values of x and y must satisfy this equation. Why? Because this point is on this line. Two is equal to 4 times 0 cubed divided by 3 plus 0 squared minus 0 plus c. So 2 is going to be equal to c, because this is 0. So this is 0 plus 0 minus 0 plus c. So that means 2 is equal to c. So what is the equation? All of this equation right here is y is equal to 4x cubed over 3 plus x squared minus x plus 2. So this equation was differentiated to give this gradient function, right? So that's why I didn't ask you to find the equation that was differentiated. Having done all of that correct, or as best as you can, and as much as you can, you would have picked up all your marks or some good amount of marks along you. All right? Concretize this in your mind from now. If there's something about this you're not sure about, you need to get that correct from right now. Concretize this in your mind from right now. If there's something about it that you're not sure about, you need to get that clarity from right now. Because if you understand this from right now and this from right now, that already cement a good portion of the question on the exam that we not have to worry about. So we need to if there's something here that we're not sure about, we need to understand why we're not sure about it right now. And there is something here that we're not sure about. We need to understand why we're not sure about it right now. Because these questions are still on the board. So I need to know why I don't know. And if I don't know, then I need to understand it like right now. Because if something like this is coming on the test, I need to be able to know that I can do this because I understand it right now. Not the graph part, because it's not going to be necessary for you to draw the graph, right? But everything from right here going down, which is the calculation, if you don't understand, I need to know why I don't understand. Right.
Sir, so what if like you get like a fraction start so like right there you have 2x here. What did you say? 2x here over so what?
You're not changing nothing. Let's say so if you're saying that this was like y is equal to 2x squared over 3 plus 3 same way, then the integral is still the same. So you add 1 to the power and what do you do next? When you're integrating, you add 1 to the power and then what? Everybody are one class. When you're integrating, you add 1 to the power and then you divide by the new power. So if I'm going to integrate here, it's going to be 2x add 1 to the power, I get 3. But notice it is already over 3, right? Which is this 3. But then I'm going to divide by the new power, which is 3 again. Which means that the denominators will multiply. So as we say, concretize those things in our minds. So you're telling your mind right now, mind, what about this I'm not sure about? Asking yourself the question, what about it? Because we are trying to eliminate the stress before the exam. What about this I'm not sure about right now? So if I see a question that looks like this, if it are come on the test. If I see a question like this, if it is coming on the test, what about it would I not able to do? And if so, I need to get that clarity right now. If I see a question like this on the test, what remember this doesn't it's not one of those that have the power like say square, cube, all of that. Right? So and if I say that yes, I do understand this, then you take the stress off of your mind. Because you don't want going to the exam with stress. Because if you do, the things that you know, they will go. I'm telling you. Because you can't think through all of that anxiety and that stress. And that is the reason why when some persons are put in some difficult situations, sometimes they will make a decision that they think is the best, which will end up being a bad decision in the long run because you're thinking under pressure and not everybody's thought or know how to think through pressure and make the best decisions possible. And that is the reason why sometimes, persons who are in some positions, they will run them through some simulations of what if, what if, what if, and see how they think quick on their feet and how they carry out whatever action they are. And then after that, they ask them, so why you do this? What if you did this instead? What do you think would happen? Why you never do it this way? Right? Because they want to know, allow them to know, see that there are options. And while you're thinking, you must be considering the impact, who's going to be affected, all of those things. So I'm carrying you through this process now for you now to start thinking, do I know this? Do I know this? Do I understand it? What about it I need clarity on or whatever the case may be? So that by the time you have the conceptual knowledge of how to work through it from now, by the time you see it on the test, you can say, okay. All right.